Hello and welcome back to part 2 of the GeoPython Advanced workshop. In part 1 we've recorded a macro which generates a fiber structure and then runs a flow simulation and outputs the permeability. Then we have reorganized this code into a neat function that we can call, which we will now make use of in part 2. In part 2 we will look at loops, automatic optimization of material properties and plot generation. Now to begin, let's go back to Notepad++, where we had our file workshop3.py. If it's not open, open it again. And first thing we want to do is save this as, file save as, workshop4.py. Now remember that in the last macro we called our function with a single fixed SVP value of 25. And we then displayed the resulting permeability value. What we want to do now is we want to loop over several different SVP values and display the result for each. So in order to do this, we begin by deleting these two lines. And we start with a for loop. For SVP in range 5, 50, 5. So the range construct basically constructs something like a list of values. It starts with 5 in this case, increments by 5 until it reaches the upper limit of 50, whereas that limit is exclusive. So this means we're going to have values 5, 10, 15, up to 45 inclusive. And what this for loop does is it assigns each of these values to the variable SVP in turn. So everything that we are now going to write into the body of the for loop is going to be executed for each of the values in the range. And what we do here is, again, we use the variable perm equals create structure and run simulation with the argument SVP, which is the for loop variable. And then again we display the value, but this time we're going to be using a string formatting to give a nicer message. So we do f single quote the permeability for a SVP of curly bracket SVP is curly bracket perm. So what this does, it constructs a string which has the values for the SVP and the permeability inserted at these points. Now save the file again by pressing Ctrl S. Go back to Geodict. Open the macro execution dialog if it's not already open by going to macro, execute macro script. Refresh. Select the file workshop4.py and run. And as you can see here, the first thing that happens is you get a message for an SVP of 5. You get the corresponding permeability here. If you press OK, you get the value for 10. And it continues like this. Might have to click override once or twice. And you see that it iterates over all these values of solid volume percentage, creates a fiber structure with that given solid volume percentage, and computes and outputs the permeability. In the next step we want to take these permeability values and plot them against solid volume percentages. For this, go back to Notepad++, go back to workshop4.py, and first of all, save it as workshop5. Now we go and remove the for loop. And first of all, we want to import the plotting library. Make sure you're at the beginning of the line and then type import matplotlib.pyplot as plt. Matplotlib is a plotting library, and pyplot is a simple interface to that plotting library. And we have just imported that pyplot submodule under the name PLT. Next, we want to store the SVP values in a list because we're going to be using them 2 times. So SVP values equals list range 4, 50, 5. Again, this is so we don't have to type out this range twice because we need it twice this time. And this is now stored in a list. So SVP values is a list of the values that we saw earlier. So it's a list of the values 5, 10, 15, etc. up to 45 inclusive. And for the permeability values, we allocate an initially empty list. And we're now going to be writing a for loop which iterates over these SVP values, computes the permeability for each, and stores the resulting permeability at the end of the perm values list. So that in the end we end up with 2 lists of equal length, with the list SVP values containing the SVP values and perm values containing the corresponding permeabilities. So now our for loop looks like this: for SVP in SVP values, which does the same thing as the for loop we had before. Now again, indent the loop body by pressing tab and write perm equals create structure and run simulation of SVP. And now we write perm values dot append perm in round brackets. So what this loop now does is, again, it iterates over the SVP values, computes the permeability, and for each permeability, that permeability is appended to the perm values list, which is initially empty. Now, under the for loop, again, make sure you're now at the beginning of the line, because the part we're going to add now is not going to be part of the for loop body. We write plt.clf. This is for clear figure. This clears any remaining plot. So you can make sure that you start with a clean slate, basically, if you run this macro several times. And then plt.plot SVP values, comma, perm values. The plot function basically plots XY values, so it gets 2 lists. It gets a list of X values and a list of Y values, and it does a line plot over these. And now, last but not least, we want to save that plot. So we write plt savefig brackets and now a string permeabilities dot png. So what this does, it computes the permeability values, plots the permeabilities against the solid volume percentage, and saves that plot as permeabilities.png. Now please save the file workshop5.py by pressing Ctrl S and go back to the geodict macro execution control, macro execute macro script. Again, hit refresh here, select the workshop5.py macro and click run. Now again, you'll have to press override several times because the results are already there. And now we can go to our project folder in Explorer. And here we can find the file permeabilities.png, which is an image file containing the plot we just generated. Double click it, and you can see that, we have generated a basic plot. On the x-axis you can see the SVP, and on the y-axis you can see the permeabilities. If you want to augment the plot, maybe by adding a title or adding labels, please refer to the matplotlib documentation. Now for the last exercise in the second part of the advanced workshop, I want to show you how you can make a simple, fully automatic material optimization loop. Namely, what we want to do is we want to give a target permeability, and we want to use GeoPython to automatically determine a solid volume fraction which produces a matching permeability. So let's go to the editor again, to Notepad++, and again, as always, save workshop5.py as workshop6.py. And now again, we're going to get rid of the of all the code we added under that function. So starting with the import line to the end of the file, get rid of that. And now, first thing we want to do is we want to define a target permeability. So let's define a variable called target_perm equals 10e minus 12. So that's the permeability that we want to hit. Also, we'll define a minimum and a maximum SVP, which basically makes up our search space, which is being considered in the optimization. So let's say SVP min is 5 and SVP max is 50. Now what we're going to do is basically we're going to be doing a bracketing search. So now we're going to start again with the for loop, but in this case the loop is not over the SVP values, but over the number of optimization steps that we want to take. Let's just say 10. So we have 10 steps of optimization because the for loop will be executed 10 times. And we first compute the SVP that we want to consider at this point. So SVP equals SVP min plus SVP max divided by 2. And this is basically the midpoint of the interval that we are considering right now, the interval from SVP min to SVP max. We take the midpoint of that, and then we compute again the permeability for that SVP value. So perm equals create structure and run simulation of that SVP value. Now what we're going to do is we're going to look at the permeability value that we just obtained, and then we change the considered interval depending on if it's larger or smaller than our target permeability. So we do if perm is larger than target perm, then what we do is we change SVP min to SVP. Basically, we change our lower limit to the midpoint. Else, colon, SVP max equals SVP. And by this procedure, we basically incrementally bracket the target SVP value. And again, here the indentation is really important. So we have 1, 2, 3 levels of indentation. We have the top level here with the 4. Then we have the loop body, which starts 1 tab in. And inside the if, we have 2 tabs in front of the line. And it's important to match this. So now, outside of the for loop, so at the very beginning of the line, we write gd message box. Again, F for format, quote, final SVP, and permeability. So this loop incrementally brackets the correct SVP value to match our target permeability. And at the end, the SVP variable value, and the perm variable value will still have the value of the last iteration of the loop, which is hopefully close to the target value. Now let's go back to Geodict and try it out. Press Ctrl S to save the file, workshop6.py. Go back to Geodict. Go to macro, execute macro script. And if you don't see workshop6.py here, just click refresh and select workshop6.py and press run. You might be asked to override again, just click override. And now it automatically basically homes in on the correct SVP value to match the permeability that we want. Should just take a few seconds. Of course, you can do this with larger structures as well and leave it running overnight or even over weeks. So, and this is the final result. We get an SVP of about 19.5 and a permeability about 9.9 E-12. And we had a target permeability of 10 E-12, so that's pretty close. And of course, you can do this kind of optimization with other kinds of generator parameters. Doesn't have to be the solid volume percentage or the porosity, but you could, for example, vary the diameter of the fibers or vary the orientation distribution, and you can also simulate other parameters, mechanics or whatever you want, and basically optimize for that. And with this I want to conclude the second part of the GeoPython Advanced workshop. In the third part, we're going to be looking at how you can automatically generate PowerPoint slides from your simulation results.